Welcome to G Fun Facts Online, where we dig into the science that's shaping our future. Today, we're going to the moon. Not just for a quick visit, but to stay. Humanity is on the verge of becoming a multi-planetary species, and a permanent moon base is a huge part of that dream. But any home needs power, and on the moon, that's a massive problem. Imagine trying to ship a solar panel from Earth. It costs nearly €1 million to send just 1 kilogram into space. Powering a whole lunar city that way would be impossible. So, how do we solve this? The answer isn't in a rocket cargo bay. It's already on the moon, right under our feet. The key is the ubiquitous lunar dust, also known as regolith. This isn't just dirt. It's a treasure trove. Lunar regolith is packed with silica, alumina, and calcium oxide. In simpler terms, it contains the two most important ingredients for solar panels: silicon and oxygen. And there's a virtually limitless supply. This idea of using local resources is called in situ resource utilization, or ISRU. It's the ultimate form of living off the land, and it's how we'll build a self-sufficient future in space. So how do you turn dust into electricity? Let's look at two incredible approaches. First up, researchers at the University of Potsdam in Germany have created what they call moonglass. They took a simulated lunar regolith and heated it to about 1,550 degrees Celsius in a vacuum furnace. This melts the dust into a semi-transparent glass, which becomes the base for a solar cell. On the moon, you wouldn't even need a furnace. You could just use a giant lens to focus sunlight and generate that intense heat. Once they have this moonglass, they deposit a very thin layer of a material called perovskite on top. Perovskite is a wonder material for next-gen solar cells. It's lightweight, cheap, and incredibly efficient at capturing light. Just 1 kilogram of perovskite could theoretically produce 400 square meters of solar panels. But that's not the only game in town. Blue Origin, the space company, has a project called Blue Alchemist that takes things a step further. Their process uses molten regolith electrolysis. They run an electrical current through the melted moon dust, which separates all the elements. This process extracts iron, aluminum, and most importantly, silicon that is over 99.999% pure, exactly what you need for high-quality solar cells. And here's the best part. A major byproduct of this process is oxygen. That's not just a waste product. It's breathable air for astronauts and a key component for rocket propellant. Blue Origin has already demonstrated the entire production line, from creating the fake moon dust to fabricating working solar cells, complete with the protective cover glass. Of course, building and operating a factory on the moon isn't easy. The lunar environment is harsh. There's no atmosphere to block intense solar and cosmic radiation, which can degrade electronics. But here's a fun fact. The moonglass solar cells are actually more resistant to radiation than the ones we make on Earth. Standard glass turns brown in space, but the iron impurities in the moonglass help it stay stable. Then there's the dust itself. It's fine, abrasive, and electrostatically charged, so it sticks to everything, potentially covering up the solar panels. NASA is already working on solutions for this, like vertical solar arrays that are less likely to get covered. The ability to make solar panels on the moon is a complete game changer. It slashes the cost and complexity of a long-term human presence. Scientists estimate that a robotic manufacturing plant could build a megawatt capacity power grid within just a few years of operation. Now, you might be thinking, are these moon-made panels as good as the ones from Earth? Right now, no. The moonglass cells have about 12% efficiency, while high-end panels on Earth can reach 30 or 40%. But that doesn't matter. As lead researcher Felix Lang put it, if you cut the weight by 99%, You don't need ultra-efficient 30% solar cells. You just make more of them on the moon. The journey from dust to a lunar power grid is just beginning. But the science is solid, and the progress is fast. The science fiction dream of a lunar colony is becoming a self-sustaining reality, powered by the very ground it's built on. Thanks for tuning in to Fun Facts Online. Join us next time for another look at the amazing world of science.